So this p-value is nothing more really than a probability. So p-value is really short for probability value. Assuming that our null is true and that the observed outcome, aka our sample, would be so extreme or even more extreme. In other words, the probability that it would be that far away. And therefore, it's a measure of the strength of evidence against, remember we said that's what we were looking for, was the strength of evidence against our null hypothesis. So the smaller our p-value, then the stronger our evidence against H sub O. Because if that p-value is really, really small, then that means the chances of getting that sample are really extreme if the null hypothesis is true. In other words, we're not expecting it to be really far away. If the null hypothesis is true, then we would expect to get a sample that has a sample mean pretty close to that. And so then, if our p-value is small, in other words, that probability is really small, that'll cause us to reject our null hypothesis in favor of the alternative. And if our p-value is large, in other words, the chances of getting that sample are really great, then we'll fail to reject the null, and because we won't have enough evidence for the alternative. And then last but not least, the one thing as you do these hypothesis tests is that you must always write your conclusions, of course, in context. So you'll have to put words to it. So going back to our 911 call problem, if you remember back in the previous problem, problem 4, we actually calculated the t-value, the test statistic for 6.48, which was negative 2.2. And so now we're interested in the p-value for that. So we're going to switch over to our formula sheet, and we have to remember the degrees of freedom for this problem was 399, but of course if I go look at the table, 399 isn't in there, so I'm going to use, I have to use the next lowest one, which is 100. So when I look at the 100 row, now here's what you need to notice is that, remember, this table reads from the right, which means that my test statistic would be positive if it were on the right. And just like on a normal bell, it's symmetric. So if I'm looking for t equals negative 2.22, I'm not going to find it in the table. Instead, I'll have to use his mirror image, which would be 2.22. But that's okay because the area that would be to the left of t equals negative 2.22 is going to be the same as the area to the right of positive 2.22. All right, so now I'm looking at row 100 and I'm checking to see where I have 2.2. So as I read across, what I notice is that it would fall in between these two values. 2.2 would live in between there. And then I'm going to read up, and this is going to tell me the area to the right. So my area to the right is somewhere between 0.02 and 0.01. Ooh, that's really small. So my p-value is less than 0.02 but greater than 0.01. Remember, on the next problem, we had a test statistic that was negative 0.9. And again, I'm going to use the same degrees of freedom. So it was 399 because we had a sample size of 400. Remember, degrees of freedom is one less. So I'm going to use 100. And I'm also going to look up positive 0.9. So when I go over here, I'm looking in that same row, but now I'm looking for 0.9, and I notice that it would be between these two values right here. And again, if I read up, it'll tell me the tail probability, because that's what the top does, is between 15% and 20%. And then I say, wow, that's really high. So my p-value for this one is between 0.2, should be at less than, and 0.15.